Good afternoon, students. Welcome back to Electromagnetic Waves and Transmission Lines course. This is Dr. Y. Pandu Rangaiah, Associate Professor, Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering. So in the previous class, we discussed about the vector algebra and as well as the coordinate systems. With respect to the vector algebra, we discussed about what is a vector, what is a scalar, what is an unit vector, what is a component of a vector, and to that the other vector, what is a vector addition, multiplications, where the scalar product and as well as the vector product we discussed. And also with respect to the coordinate systems, we've gone with the 3-axis coordinate systems, where we have rectangular coordinate system or Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. So with respect to all these 3 coordinate systems, what are the coordinate axes and the ranges of those coordinate axes, and how to locate a point onto the coordinate system, and how to transform a point from one coordinate system to the other coordinate system, the representation of a vector in all these 3 coordinate systems, and how to convert a vector from one coordinate system to the other coordinate systems, which we discussed in the previous class. So this class will go ahead with what are the constant coordinate surfaces in case of all these 3 coordinate systems, and also we'll go ahead with what are the differential lengths, differential surfaces and volumes in case of these 3 coordinate systems. So after this completion of this course, the students will be able to differentiate the orthogonal surfaces with respect to all the coordinate systems, and also they can know that how to calculate the area and volumes of the cylinder and cylindrical surfaces. So we'll go ahead with the coordinate systems. As we know that we have 3-axis coordinate systems. They are the Cartesian coordinate system, cylindrical and spherical coordinate system. The 3 mutual perpendicular coordinate axes in Cartesian coordinate system are x-axis, y-axis and z-axis. Whereas in cylindrical coordinate system, the 3 perpendicular coordinate axes are rho-axis, phi-axis and z-axis. In spherical coordinate system, the 3 perpendicular coordinate axes are r, theta and phi axis. Now let us come to the constant coordinate surfaces in rectangular coordinate system. So it is a surface is nothing but where the 2 axes or the 2 variables are varying and one variable is the constant. Suppose if I say that it is an xy plane or xy surface where it is an z component is constant. The x is variable and y is variable and the other variable is z is constant. So if a surface is nothing but the 2 variables are varying and one variable is constant. If an xy plane, z is equal to constant, and if it is an yz plane, x is equal to constant, or if it is an xy plane, z equal to constant. So for the constant surfaces, 2 variables are varying and one variable is constant. In Cartesian coordinate system, we will find those constant surfaces are 3. X equal to constant surface, or we can say that it is an yz plane, y equal to constant surface, or we can say that it is an xz plane, or z is equal to constant, which is an xy plane. All these 3 surfaces are perpendicular to each other. Suppose if x is equal to constant, y is varying and z is varying. Y is varying from minus infinity to the plus infinity, whereas z also varying from minus infinity to the plus infinity. So x is equal to constant is an infinite plane. Similar way, if y equal to constant, other 2 variables x and z are varies infinitely long from minus infinity to the plus infinity. Therefore, y is equal to constant is also an infinite plane. Similar way, for z is equal to constant, x and y are varies infinitely long from minus infinity to plus infinity. Therefore, z is equal to constant is also an infinite plane. Means In rectangular coordinate systems, the three perpendicular constant coordinate surfaces are infinite planes. So a point onto the rectangular coordinate system is the intersection of three perpendicular infinite planes, which are x is equal to constant, y equal to constant, and z is equal to constant. We'll go ahead with cylindrical coordinate system. In cylindrical coordinate system, the three mutually perpendicular coordinate axes are rho axis and phi axis and z axis, where rho is called as the radius of a cylinder, and phi is called as an azimuth angle, and z is equal to, similar as rectangular coordinate system, the same axis, where the rho is ranging from 0 to infinity, phi is changing from 0 to 2 pi, whereas z is equal to varying from minus infinity to plus infinity. Let us now look at what are those constant coordinate surfaces in cylindrical coordinate system. First one I will take it is an rho equal to constant. I will take that the radius of a cylinder, that the rho equal to constant I will take, and I will make to vary that the phi and as well as the z. Phi is varying, moving from 0 to 2 pi. It is varying from 0 to 2 pi. Means it is an one full circle rotation, azimuth angle. And by varying phi equal to 0 to 2 pi, and I will move that the z is equal to, also I will move from minus infinity to the plus infinity. Means it will give as an rho equal to constant for the different values of the rho. It gives by varying phi from 0 to 2 pi and also the z from minus infinity to plus infinity, will get a circular cylinder. Rho equal to constant is a circular cylinder. Similar way, I will go with the next variable. I will keep phi equal to constant at an angle somewhere. Assume that at phi equal to 30 degrees, I will keep it as a constant. Phi is the angle which is measured from the x-axis in an anti-clockwise direction in an xy plane. So I will keep from the x-axis, phi is equal to some 30 degrees. For example, I will keep the constant. Phi is constant, but I will vary that the rho. Rho is varying from 0 to infinity. Rho is varying from 0 to infinity in this angle. Similar way, the z is varies from minus infinity to the plus infinity. So I will keep the phi is equal to constant. I will start to vary that rho from 0 to infinity and z from minus infinity to plus infinity, which gives us a semi-infinite plane. Phi is equal to constant will give a semi-infinite plane, whereas the rho equal to constant is a circular cylinder. Now I will go ahead with z is equal to constant. If I keep the z is equal to constant, I need to vary rho and as well as phi values. Rho I am varying from 0 to infinity. Rho I will vary from 0 to infinity. And again phi also I will move from 0 to 2 pi. So I will get it is an infinite plane I will get for z is equal to constant. So in cylindrical coordinate system, we will get the three constant coordinate surfaces are, one is a rho equal to constant is a circular cylinder, and phi is equal to constant is a semi-infinite plane, and z is equal to constant is an infinite plane. Therefore, a point onto a cylindrical coordinate system is the intersection of a circular cylinder and a semi-infinite plane and an infinite plane. So these are the three mutually perpendicular coordinate surfaces in case of cylindrical coordinate system. We'll move on spherical coordinate system. In spherical coordinate system, the mutually perpendicular coordinate axes are r-axis, theta-axis, and as well as the phi-axis. R is the varying from 0 to infinity, whereas the theta varies from 0 to pi, and phi will be varies from 0 to 2 pi. So if I keep it is an r equal to constant, let us take that one variable r equal to constant. So I am varying it is an theta I am varying, phi is variable. If theta varies from 0 to pi, it is an elevation angle. It is varies from 0 to pi. With respect to the z-axis, theta is an angle which makes with z-axis in clockwise direction and which varies from 0 to pi. So as it is varying from 0 to pi, whereas the phi is varying from 0 to 2 pi. So theta is varying from 0 to pi and phi is varying from 0 to 2 pi. We will get it is a surface is an sphere. By keeping r equal to constant, by varying theta and phi values, we will get a surface which is an sphere will get. So this is r equal to constant is a sphere. Whereas if I keep it is an another variable, if I keep theta is equal to constant and if I vary that r value and phi value, r is varying from 0 to 2 pi, r is varying from 0 to infinity and phi is varying from 0 to 2 pi. I will keep some theta is equal to constant with the z axis. This is the z axis if I assume. I will keep it is and the theta equal to constant. Then I will start to move it is and 0 to 2 pi. 0 to 2 pi, phi is variable and also r also variable from 0 to infinity. We will get it is an a circular cone. Circular cone with the z-axis as its axis. Circular cone with the z-axis as its axis because theta is an angle which makes with the z-axis in clockwise direction. So by keeping theta is equal to constant and varying r and as well as the phi component, we'll get it is a circular cone. So which is shown here, r theta is equal to constant. Similar way, if I keep the phi is equal to constant and if I make vary r and as well as the theta, r is a variable which is changing from 0 to infinity and theta varies from 0 to pi. So 0 to pi in this direction and again it goes from 0 to infinity. I will get only a semi-infinite plane which is same as in cylindrical coordinate system. So the phi is equal to constant which gives as a semi-infinite plane. So in spherical coordinate system, the constant coordinate surfaces are equal to constant which gives a sphere with the center at the origin and theta equal to constant is a circular cone with the z-axis as its axis and phi is equal to constant is a semi-infinite plane. Therefore, a point onto a spherical coordinate system is the intersection of a circular cone, a sphere and a semi-infinite plane. So these are the three mutual perpendicular coordinate surfaces, constant coordinate surfaces in spherical coordinate system. Now we'll move to the next topic, the differential lengths, areas and volumes with respect to these coordinate systems. Let us will consider a rectangular coordinate system. In rectangular coordinate system, the three coordinate axes are x-axis, y-axis and z-axis. What are the differential displacement length in x-axis? If an x value will be, the variable x is increased by a differential amount of dx. What is the total incremental length in x-axis is given by dx ix. Whereas because of it is only length, there is no angles are involved. Therefore, whatever the amount of the differential displacement which we do that in that with respect to x or y or z axis and it is increased by the same amount. Therefore, if an amount of dx, the differential length is increased in x direction, the total length increase in x direction is dx ix. Similar way, in y direction it is an dy iy. In z direction, dz iz. Whereas if I go for the area, what is the differential normal areas are given by, if I take it is in x direction, so if I keep it in x is equal to constant, then the y is variable and z is variable. So the incremental length in y direction is dy, incremental length in z direction is dz. So the normal area in x direction, that is for yz plane, is dy dz into ix. Similar way, the normal areas for xz plane, dx dz iy, and for yz plane, dy dz iz. So for areas, two components are variable, two two are variable and one is constant. YZ plane, it is an x is equal to YZ plane, it is an x is equal to constant. If it is an XZ plane, y equal to constant, or if it is an XY plane, Z is equal to constant. Whereas if I take it is in a differential volume, where that x will be variable, y is variable, and z also variable. All the three are variables. So the differential volume is given by dv equal to dx, dy, dz. So these are the differential displacement, differential normal areas, and as well as differential volume in case of rectangular coordinate system. But which is not the same case if I go for the cylindrical or spherical coordinate system. Let us will see that in cylindrical coordinate system, what are those the differential displacements, normal areas and volumes. Let us will go ahead with the spherical coordinate system. In spherical coordinate system, suppose if the rho is varied by an amount of dl, it is in a length. Therefore, the total incremental length is d rho only. Total incremental length in rho direction is d rho only. Whereas if we increase that in phi direction by an amount of d phi, what is the total incremental length in the phi direction, which is given by not d phi. So let us, I will explain here. If I take it is an in phi direction, suppose if it is an x-axis, y-axis and z-axis, if it is the rho, and this is the phi, if I increase the phi by an amount of the d phi, so there is an arc, and this arc length increased in phi direction, it is given by not d phi, it is given by rho d phi. The total incremental length in phi direction, if in the phi direction, if we increase by an amount of d phi, the total incremental length in the phi direction is given by rho into d phi. That is the difference here as compared to the ordinary lines as well as x, y, z axis and rho axis. But it is the angle is increased by an amount of d phi. The total incremental length in the phi direction is rho into d phi. Whereas in z direction, if I increase that the length by small amount of dz, the total incremental length, because of it is in a distance, there is no angles are involved. So the effective incremental or displacement is given by, differential displacement is given by dz only. So here the difference is, if rho is increased by an amount of d rho, the total incremental length in rho direction is given by d rho I rho. Whereas if phi is increased by a differential amount of d phi in phi direction, the total incremental length in the phi direction is given by rho into d phi into I phi. Whereas in z directions, if it is increased by an amount of dz, the total incremental length in the z direction is dz by z. So coming to the normal areas, if I take in rho direction, so there is an incremental length in phi direction as well as z direction. Phi direction, the incremental length is given by rho into d phi, whereas in z direction, the incremental length is dz. So the incremental length in rho direction normal area for phi z and phi plane, where rho is equal to constant, is given by rho d phi dz into I rho. Similar way, if I go for I phi direction, normal area in I phi direction means rho is increased and z is increased. Rho is increased by d rho and dz. Similarly, in IZ direction, phi is increased and rho is increased. Incremental length in the rho direction is d rho and incremental length in phi direction is rho into d phi. These are the incremental normal areas in cylindrical coordinate system. So if I consider the volume, all that there is an increment in rho direction, phi direction and z direction. All these three are variables. So dv is given by incremental length in rho direction is d rho, incremental length in phi direction is rho d phi, incremental length in z direction is dz. So here there is the concentration is only in phi direction. If there is an incremental length in phi direction is by d phi, if an angle is increased by an amount of d phi in phi direction, the total incremental length in phi direction is given by rho into d phi. This is only the difference as compared to rectangular and cylindrical coordinate system. Since phi is the angle, as the angle is changed by a small amount of d phi in phi direction, the total incremental length in the phi direction is rho d phi. Now we'll move on to the spherical coordinate system, where in spherical coordinate system we have two angles, theta is exist and as well as the phi is exist. Now we look at it in r direction. In the r direction, if there is an incremental length of dr, the total incremental length in the r direction is dr itself. Whereas in theta direction, if I increase an amount of the angle by d theta, then the total incremental length in theta direction is given by r into d theta. If an angle is increased by an amount of d theta in theta direction, the total incremental length in theta direction is r d theta into I theta in theta direction. Similar way in phi direction, the component of r onto the rho bar vector is r sin theta. The component of r onto the rho bar vector is r sin theta. Therefore, if phi is increased by an amount of d phi, then what is the total incremental length in the phi direction is r sin theta into d phi. This is an incremental length in phi direction is r sin theta into d phi. So, if an angle phi is both angle is increased by an amount of d phi in phi direction, then the total incremental length in the phi direction is given by r sin theta d phi I phi. Therefore, the normal areas will becomes, if I take in r direction, so the theta is varied and phi is varied. Theta is varies by r sin theta d theta. Theta is varied as r into d theta, and phi is varies in the phi direction r sin theta d phi. Therefore, in IR direction, the normal area is given by r square sin theta d phi. Similarly, if I go in I theta direction, then it is an r direction is increased and also the phi direction is increased. In r direction only it is an the dr. In phi direction r sin theta into d phi. Similarly, if I go for I phi, where the dr is in r direction is increased and theta direction is increased. In the r direction it is a dr, in theta direction it is an r into d theta. So these are the normal area, differential normal areas in case of spherical coordinate system. Then if I move on to the volume is nothing but it is increased in r direction, theta direction and phi direction. The incremental length in the r direction is the dr, and the incremental length in theta direction is r into d theta, and the incremental length in the phi direction is r sin theta into d phi. Therefore, the incremental volume is given by r square sin theta dr d phi. So, this is about the differential length, area and volumes in case of the spherical coordinate system. So, I will summarize that what we discussed in this class is we gone with the review of the coordinate systems, and we have been seeing that what are the constant coordinate surfaces in case of rectangular coordinate system. There are the three constant coordinate surfaces which are perpendicular to each other in rectangular coordinate systems. Those are x is equal to constant, y equal to constant, z equal to constants. All these three are the infinite planes. Whereas in cylindrical coordinate system, the constant coordinate surfaces are the circular cylinder, if the rho equal to constant, phi equal to constant, it is a semi-infinite plane, and z is equal to constant, it is an infinite plane. And in spherical coordinate system, the constant coordinate surfaces, those three perpendicular to each other are r equal to constant is a sphere, and theta is equal to constant is a circular cone, and phi is equal to constant, it is a semi-infinite plane. So a point on these three coordinate systems is an intersection of the mutually perpendicular coordinate surfaces, constant coordinate surfaces. And also we discussed what are the differential displacements, different normal areas, and also that the differential volumes in case of rectangular coordinate system, cylindrical coordinate system, and spherical coordinate system, where in rectangular coordinate system, if x is increased by an amount of dx, y is increased by amount of dy, z is increased by an amount of dz, the incremental length in all x, y, and z axes are dx, dy, dz only. Whereas in case of the cylindrical coordinate system, if phi is increased by a differential amount of d phi, the total incremental length in phi direction is rho d phi. Whereas in spherical coordinate system, if the theta is increased by an amount of d theta, the total incremental length in theta direction is r into d theta. If phi is increased by an amount of d phi in spherical coordinate system, the total incremental length in phi direction is r sin theta d phi. So by considering those, and we have been explained what are the differential normal areas and differential volumes in case of cylindrical and spherical coordinate system. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.